record. Okay, so here we are in 5th period class, and we are going over Chapter 4 test ins 25 through 35, and everybody's going to go to Moodle to make sure that they get the other parts that their class did not see.
Should we leave
Ready?
like 25 spaces for the other ones, or should we just start at the top?
However you want to work. Whatever you want to do. Okay, question 24 and 25 go together. We're describing Rutherford's gold foil experiment and its effect on atomic theory. So, what did Rutherford do in his experiment? Shot alpha particles, which are positively charged particles, high energy, and he shot them at gold foil, which is going to be orange because I don't have a gold marker. Okay? And what did those alpha particles do? Most of them just went right through. What did some of them do? They bounced off maybe at some angle. Some of them might have hit and bounced completely backwards. But the real question is, why were they doing that?
They were cutting extreme rates.
Yeah, so here we are at the atomic level. These are our atoms, and they have a nucleus, which Rutherford didn't figure out until he did this experiment. And our alpha particles are usually just going right through there, not hitting anything, no problem. But if they come near a nucleus, they started to bend off in different angles. Or maybe they came close and hit kind of right on, and then they bounced backwards. What can you tell me about the charge of alpha particles?
Positive.
Are you sure?
Positive.
I'm positive.
Yes. And what can you tell me about the charge of the nucleus?
Negative.
What?
It's positive.
Positive.
Also positive. Apparently you weren't sure. They're also positive. That's why those alpha particles were bending off at various angles. Okay? A positively charged particle coming near another positively charged particle will be deflected. If it was positive hitting negative, they just squish together.
What do you say about its effect on atomic theory?
Well, what was the atomic theory before then?
The atoms were solid.
Atom's kind of solid. That goes way back to Democritus. We had Thomson's model before that. What was JJ? Yeah. J.J. Thomson was telling us the plum pudding model. And that marker's not going to show up too well, but the plum pudding model, where they kind of think of a chocolate chip cookie if we don't get plum pudding. So we have chocolate chips and nuts or some other substance in there, evenly distributed throughout. Thomson thought the protons and electrons were evenly distributed throughout. Rutherford's experiment showed that the nucleus, all the protons were condensed in a small area right in the middle. Okay? So we modified that theory to bring in Rutherford's experiment. Number 26. Oh, this is an awesome question. Identify the number of particles in a mole. We're going to be all over this today in our lab. Are you with me? Absolutely. We're finishing beans today, and it's going to be all about the mole. How many particles are in a mole? 6.02 times 10 to the 23rd. What if it's a mole of carbs?
That'd be heavier.
It would be 6.02 times 10 to the 23rd. What if it was a mole of praseodymium atoms? 6.02 times 10 to the 23rd. What if it was a mole of sodium ions? 6.02 times 10 to the 23rd. What if it was a mole of pickles? 6.02 times 10 to the 23rd. So what does that tell us about a mole?
It doesn't change.
It doesn't change. Doesn't change what? Number. How many are in it? Okay. 27. Explain how moles of different substances compare to each other. Okay. We have 3 different elements, but we have a mole of each. What is alike about them?
They all have the same number.
Of what is how many?
How many there are?
Same number how many there are. So say we've got 1 mole of carbon, and we have 1 mole of neon, and we have 1 mole of potassium. Okay? MOL, by the way, is the abbreviation for mole. What is something that is the same? And how many is it? 6.02 times 10 to the 23rd atoms. So they all have that. What is something that is different? The number of protons. This has 12 protons. Neon has how many? 10 protons. Potassium has 19 protons. So that's something that's different. What else is different? The number of neutrons and electrons. What else? Huh?
The weight.
The mass, or their weight. So carbon is going to have a mass of 12.01115 grams or AMUs. Neon is going to have a mass of what? 20.1797 grams or AMUs. And potassium? 39.0983 grams or AMUs. Right? So they all have the same number of atoms in there, but they have different masses. Okay, because they're a different kind of atom. Excellent. 28. Identify the charges of the subatomic particles. What are the 4 subatomic particles?
Protons, electrons, neutrons.
You guys did not test that at all.
They never do. I'm glad somebody did.
Yeah.
Right, yes, please. There are only 3 subatomic particles.
Oh.
Why is that?
Wow. But you're all trying to answer me. So, what are the 3 kinds of subatomic particles?
Protons, neutrons.
Protons, neutrons, and electrons. Well, those quarks in that are subatomic particles. And what is the charge of protons?
Positive.
Are you sure?
Positive.
Yes. How about neutrons?
Negative.
Neutral.
Neutral.
And electrons?
Negative.
Negative. Okay. Sometimes chemistry is easy. 29. Identify the isotope that is the standard of mass on the periodic table. We've actually been through a couple different elements to use as the standard, but what is the one that all of science now agrees is our reference element?
Carbon.
Carbon what?
12.
Carbon 12. So carbon 12 is now our standard of mass. And when I write it like this, what does that mean? When I write C-12, what about it? That's a what of carbon?
The average.
Sort of. Starts with an I. Isotope. That's an isotope of carbon. It's the most abundant isotope of carbon, and that is why it is chosen as a standard. Well, and other reasons. Okay, number 30. Define the law of multiple proportions, definite proportion, and conservation of mass. This will be based on what we found in the FSR lab, only we're going to use real elements instead of fasteners and rings in this question. And this one is 4 lines long of text, and people look at that and think, oh my gosh, I can't do that one. Oh my gosh, yes you can. It's actually really easy. Okay? The answer is either A, B, C, or D. Okay? So they're going to have you compare the mass of one element to another and ask you what this demonstrates. So here is this